Okay, I'm going to introduce you to Pascal's triangle, often used with rather than the binomial theorem, and how it will help. I think that Pascal's triangle is used in a variety of ways in mathematics, but how we're going to be using it, Algebra 2, college algebra classes, is to expand binomials. So this level right here represents the constant coefficients outside of binomial squared. This one represents a cube. This one represents a binomial to the fourth power, etc. If you don't remember this, here's a cool thing to remember. If you notice, those rows, look at this. You have 1. Well, that's 11 to the 0. Whoops, 11 to the 0 power. Then you have 1, 1. Well, that's 11 to the first power. Then you have 1, 2, 1. That's 11 squared. 11 cubed is 1331. 11 to the fourth is 14,641, etc. The problem is, as soon as you get to this level, it no longer works in the calculator because the numbers carry. So this is what you need to remember on each of these rows. So look at what we have here. Since the fifth, it's actually the sixth level, but a binomial to the fifth. Let's say that there's an invisible 0 here and here. 0 plus 1 is 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. 1 plus 0 is 0. Same with this next level. 0 plus 1 is 1. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. You get the idea? So up until binomials to the fourth, you can plug in 11 to a level and it will give you what those coefficients are. All right, so here's how you use that. You use those rows, left off the 1 right there, and then the powers are, the first term is in descending order, so x squared, x to the first. That's supposed to be a y right there. Oh, I'm glad I'm catching these mistakes. That would be x to the 0, but because it's x to the 0 is 1, we don't have to write it. And then coming the other direction, the second term is y to the second, y to the first, y to the 0. So we're going to do the same thing. Hopefully I didn't make a mistake with the x's and y's. Look what we have. We have 1, 3, 3, 1. And then the first term, x, will be in descending order. X cubed, x squared, x to the first, x to the 0, we don't have to write it. And then from the other direction, we have it in descending order going left. X cubed, x squared, y cubed, y squared, y to the first, y to the 0, so we don't have to write it. Hopefully you're seeing the pattern. So the first term, x to the fourth, x cubed, x squared, x to the first, x to the 0, we don't have to write it. So in the reverse direction, y to the fourth, y cubed, y squared, y to the first, y to the 0, we don't have to write it. So that just gives you the basic intro to Pascal's triangle.